All right, thank you for tuning back in for part 2 of writing proofs using side, 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 and angle, side, angle. I'm going to pick up right where I left off in the last video on page 26 in your notes, and I'm going to jump right into this proof. A segment AB congruent to segment AD. So the first thing I'm going to do, mark those guys congruent. Number 2 says segment AC bisects angle BAD. So I'm going to go find angle BAD in my picture. Angle BAD is that purple guy. AC is a bisector. Bisectors go around splitting things into 2 equal parts. So I know that the 2 equal parts of that angle are therefore congruent. I'm going to mark those guys in my picture. I'm going to ask myself, are there any vertical angles that I can mark congruent in this picture? And the answer to that is no. I'm going to ask myself, do these 2 triangles share any sides that I can mark congruent? And the answer to that is yes. Side AC right up the middle is exactly the same in the triangle on the top as he is on the triangle on the bottom, and he's going to be congruent to himself. So now that I've marked all those things in my diagram, I'm going to ask myself, is this a case of side, side, side? The answer to that is no. Is this a case of side, angle, side? The answer to that is yes. So my approach or my method in writing this proof is to write about those 2 pairs of sides and their included angles. So somewhere in my proof, I need to talk about side AB being congruent to side AD. That was a given. I'm going to go ahead and put that in my proof first. Side AB is congruent to side AD. How do I know that's a true statement? Well, it's given to me to be a true statement. And because that's a pair of congruent sides, I'm going to mark it as such as an indication to myself that I've included that in my proof. Somewhere in my proof, I need to talk about side AC being congruent to side AC. That's not a given, but that's something I know because of the reflexive property. That reflexive property tells me that any object is congruent to itself. So I'm going to write about side AC being congruent to itself. I know that's a true statement because of that reflexive property. Like the first statement that I had, this one is a pair of congruent sides, and I'm going to indicate that in my proof. Lastly, I need to talk about angle BAC being congruent to angle CAD. I'm going to go ahead and put a little number in those just because it's easier for me to write about a numbered angle than a lettered angle, and you can feel free to do this at any time. So somewhere in my proof, I have to write about angle 1 being congruent to angle 2. But this wasn't something I knew from the information that was given to me or the information that I got out of the diagram. This is something that I knew because of that statement that a segment AC bisected angle BAD. So I'm going to start writing about that. So segment AC bisects angle BAD. And that's a true statement because it was given to me to be a true statement. And it was because of that whole angle bisector that I was able to draw the conclusion that angles 1 and 2 were congruent to each other. And the reason for that is because all day long a bisector goes around splitting things into 2 equal parts. So I'm going to say bisector splits angle into 2 congruent angles. And that's a pair of congruent angles, which I'm looking for to write about in my proof, so I'm going to label that with an A. So now I've talked about 1 pair of congruent sides, 2 pairs of congruent sides, a pair of congruent angles. Now I'm all set to pull all 3 of those ideas together, and I can draw the conclusion that these 2 triangles indeed are congruent because I've got 2 pairs of sides in the included angle in 1 triangle, congruent to 2 pairs of congruent sides in the included angle in the second triangle, or for a shorter, more efficient name, side, angle, side. All right, I'm going to spin up to the top of the next page and give this one a whirl. This one says segment AR is perpendicular to segment CB. So I'm going to go ahead and mark my right angles in the diagram. I also know that segment AR bisects angle CAB. So I'm going to go find angle CAB. It's that one at the top of the triangle. So that guy right up the middle, segment AR, divides that guy into two congruent parts. There are no vertical angles in the picture, but that side up the middle, side AR, is shared by the triangle on the left and the triangle on the right. So I'm going to mark that congruent by the reflexive property. And looking at this picture, I can see pretty clearly now that my approach is going to be to write that these two triangles are congruent by angle, side, angle. So somewhere in my proof, I have to write about two pairs of angles being congruent. Somewhere in my proof, I need to talk about a pair of sides being congruent. So that we can talk about them efficiently and easily, I'm going to label those two angles up at the top of my triangle, angle 1 and angle 2. And I'm going to jump right in. I want to write about angle 1 being congruent to angle 2, but it's not anything that I knew from the picture or from the given information. I knew that that was a true statement because of this whole angle bisector deal that I've got going on. So I'm going to go ahead, and I think this one I'll write in statement reason format for all you two-column lovers out there. If you'd prefer to write a flow proof, by all means, feel free to write yourself a flow proof. So I'm going to talk about segment AR bisecting angle CAB. Now, I've chosen to write about that angle bisector first. If you wanted to write about the reflexive property and side AR being congruent to side AR first, that is absolutely positively your choice. It doesn't make a difference what order you write about them in, as long as each and every one of those three pairs of congruent parts in the triangle on the left and the triangle on the right gets spoken about or talked about somewhere in your proof. So AR bisects angle CAB, that's given to us to be a true statement, and that's what told us that angles 1 and 2 are congruent to each other. Because all day long, the bisector goes around splitting whatever it's splitting up into two equal parts. So I'm going to say bisector splits the angle into two congruent angles. I'm going to cite statement 1 because statement 1 was where I was talking about segment AR. I got a typo there. I'm going to go back and change that to bisects. And since that's a pair of congruent angles, I'm going to label that as such in my proof. Somewhere in my proof, I want to talk about those right angles that are being congruent to each other. And so I can talk about them quickly and efficiently. I'm going to label them angles 3 and 4. I can't go right in and say that they're congruent to each other because I'm not given that information. The information I'm given is that they're perpendicular. So I'm going to go talk about them being perpendicular to each other. I know that's a true statement because it's given to me to be a true statement. And if those guys are perpendicular lines, I know that they must intersect to form right angles. So I'm going to go ahead and right now and talk about angle 3 and 4 being right angles. I know that's a true statement because perpendicular lines form right angles. I'm going to cite statement 3 because statement 3 was where I had those perpendicular lines. And I also know that all right angles are congruent to each other. So now I'm all set to go ahead and draw that conclusion that those two angles are congruent. And I'll cite statement 4 because that's where I knew that they were right angles. So at this point now, I've talked about one pair of congruent angles in statement 2, a second pair of congruent angles in statement 5. Now I'm going to go in and I want to, if I look at my picture, the only part that I haven't talked about yet is I haven't written anything about segment AR being congruent to itself, that shared segment that goes right up the middle of the two triangles. So that's going to be the next thing I'll write about. And I know that any segment is congruent to itself due to the reflexive property. And that was the pair of congruent sides that I needed in order to use my angle side angle. Notice that I haven't written about this in the order of angle, side, angle, but it doesn't make a difference what order I write about these pairs of congruent parts in, as long as I talk about all of them somewhere in my proof. And now that I've talked about all of them somewhere in my proof, I can go ahead and draw the conclusion that triangle ACR is congruent to triangle ABR. And that would be by angle, side, angle. And I'm going to cite statements 2, 5, and 6 because that's where I had my pairs of congruent parts listed. All right, well, thanks for sticking with me for this long. If you're feeling good about this at any time, you can feel free to go ahead and close up your notes. If you're feeling like you'd like a little bit more guidance with the proofwriting process, that's what I'm here for. All right, so the last one that we're going to take a look at is at the bottom of page 27. Our given information is, of course, what I'm going to mark first in my picture. So T is the midpoint of segment PQ. So segment PQ runs this way. Midpoints, I know, divide segments into two congruent parts. We know that segment PQ bisects segment RS. So bisects, I know, means divides into two congruent parts. So I'm going to mark RT and TS congruent to each other, but not necessarily to the first two. And we're also told that segment RQ is congruent to segment SP. So I'm going to mark those guys congruent as well. Now I see in the picture a pair of vertical angles. So I'm going to mark those two congruent as well. This is a really neat proof because you can prove these two triangles congruent by using side angle side, using the vertical angles in the middle. If you weren't feeling in a side angle side kind of mood, you could also prove these two triangles congruent by using side, side, side. So you might write your proof one way and your best bud might write it a different way, and you can both be totally correct. I'm going to go ahead and write mine using side, side, side. But again, if you want to write side angle side by using those vertical angles, definitely by all means feel free. So somewhere in my proof, I want to talk about segment PT being congruent to TQ. I knew they were congruent because of this whole midpoint thing that I've got working. So I'm going to start by talking about T being the midpoint of segment PQ. I know that's a true statement because it's given to me to be a true statement. And because that's a true statement, I'm allowed to draw the conclusion that segments PT and TQ are congruent to each other. And that's a pair of congruent sides. And that's because midpoint splits a segment into two congruent parts. In my diagram, I've marked segments RT and TS congruent. So somewhere in my proof, I need to write about that. Well, the reason I knew that those two guys were congruent was because of this whole bisector thing that I was given. So I'm going to go ahead and start writing about bisector. I know that's a true statement because it's given to me to be a true statement. And because that's a bisector, I now know that segment RT and TS are congruent to each other. And that, I do believe, is my second pair of congruent sides. And then lastly, the third pair of sides I want to write about, I know they're congruent because they're given to me to be congruent. So at this point now, I've talked about all those pairs of congruent parts. There's one pair of congruent sides, two pairs of congruent sides, three pairs of congruent sides. I'm all set to go ahead and draw the conclusion that the two triangles are congruent to each other. So those are the three parts that I need to make that conclusion. Those three statements all lead me to conclude that triangle RTQ is congruent to triangle STP. And that is, of course, by the side, side, side postulate. Well, if you've stuck with me for this long, my deepest thanks and appreciation. I hope that I've made it worth your time and the investment of your time, and that you've come to some more understanding about the whole proofwriting process. It can be tricky. It can be tough for some students. So if you're still struggling with it, please don't be afraid to ask me questions in class. Please don't be afraid to ask me questions in the math office or after school, or to seek extra help during student assistance in the math office. Again, my deepest appreciation for sticking with me this long, and we'll do some practice proofwriting the next time that you come back to class.